Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Moon Cores Approaching Earth and Fake Lunar Eclipses. Now, a lunar eclipse was observed in the sky on July 27, 2018. It was transmitted by NASA from various observatories. The footage showed many anomalies, some of which I mentioned in Article 293, entitled The Fake Blood Red Moon of July 27, 2018. Namely that the moon looked pink in some of the images, which would require blue light to be illuminating it, which is impossible, and the bright edge seen in some of the images is also impossible and indicates that this was not the real moon, but a projection. In addition, the images obtained by the observatories were no better and often worse than those obtained by people photographing or videoing the moon from the surface with their cell phones. How can observatories not get better images with their telescopes? The most likely reason is that it is a hologram in the sky at cloud altitude, and no amount of focusing or zooming in will give any better resolution than the projected image itself possesses. The largest discrepancy was the fact that the total eclipse took 103 minutes when it is not ever supposed to be any longer than 100 minutes. The actual absolute maximum value is 99.6 minutes, as I show below. And here's a photograph of the moon as seen from the Al-Sadim Observatory. As you can see, it's pink, but no blue light is supposed to get through the atmosphere at this time to reach the moon. And yet here we have a magenta moon, which would require blue light to reach it. Now, for this calculation, we need all these parameters: the sun radius, earth radius, moon radius, distance between the sun and the earth, 150 million kilometers. I give here the apogee and the perigee distances, but I'm not actually going to use them. And the mass of the earth. Now, the moon's orbit, according to NASA, changes over the course of a year, so that its minimum distance to Earth is 357,000 kilometers. So I'm actually going to use that distance to calculate the absolute maximum number of minutes a lunar eclipse can last. And no one's going to say that I didn't use NASA's own numbers, which are given here. As you can see, the moon to Earth roughly changes from 357,000 to 407,000 kilometers. This is the absolute minimum distance that the moon can be from the center of the Earth. And this is given at this web page. You can see NASA web page. Now we start by calculating the angle associated with the shadow and the distance from the center of the sun to the end of the Earth's shadow. We then calculate the horizontal length of the shadow. So here's the sun, here's the Earth, radius of the sun. This is the angle associated with the shadows. You can see this angle is the same as that angle. We have two parallel lines and a single line intersecting both. So these two angles are the same. Now this distance here is the radius of the sun minus the radius of the Earth, and tan of this angle is opposite, which is that distance, over adjacent, which is this distance, the distance between the sun and the Earth. So here are the numbers: 695,508 minus 6371. That's the radius of the Earth, that's the radius of the sun. So we can calculate that angle. It's given by this number in radians. It's given by 0.263 in degrees. And then we can use a tangent of the same angle, but using this triangle here. Opposite now is the radius. Well, we're going to use this whole triangle here. So that's the radius of the sun over opposite over adjacent. So that's opposite over adjacent. Adjacent here is R, and we're going to solve for R, and we get 151.4 million kilometers. Then we need this distance, which is the length of the shadow from the center of the Earth to the tip of the shadow. And so that's total R minus the distance between the sun and the Earth. and that gives us 1.4 times 10 to the 6 kilometers. Then, because this distance is 150 million kilometers, so we're going to just get 1.4 left. Then the size of the shadow, which would be the vertical length of the shadow at the position where the moon is, so it's from here to there, is basically about the same as the arc length associated with this whole angle from here to there, so twice the angle theta s. So that would be 2 theta s times the distance from the tip of the shadow to the moon. So it's this distance here, or this pink distance here. So that would be this distance minus this distance from the center of the Earth to the center of the moon. So that's 1.4 times 10 to the 6 kilometers minus the absolute minimum distance that the moon can be from the Earth. That's 3.57 times 10 to the 5 kilometers. And from calculating that, we get 9,583 kilometers. So this is the size of the shadow here. Now we also need the speed at which the moon will be moving at that distance. And if we calculate it for this distance, 3.57 times 10 to the 8, this is in meters, it's 1.056 kilometers per second. But to make sure that we're going to get the absolute maximum possible time, we'll actually use the moon's average speed, which is 1.022 kilometers per second, as provided by NASA's fact sheet. Where is that? There we are. Mean orbital velocity in kilometers per second, 1.022. So we're going to use NASA's mean. I think that's very fair. So we're actually going to use that. So next we need to realize that the moon is only in totality when the whole moon is inside the shadow of the Earth. So the moon, whose position is defined by its center, is in totality for a distance which is less than the vertical size of the shadow, as I've shown here. So the moon has to be completely in the shadow, so that's the edge of the moon, but its position is defined by its center. So that its center will be a length of equivalent to its radius from the edge of the shadow. So that means that this is actually the distance that the moon has to move through, or the center of mass of the moon moves through inside that shadow. So that would be the total size of the shadow with 9583 minus twice the radius of the moon, divided by the speed, 1.022 kilometers per second, and then we change units from seconds to minutes, and we get 99.6 minutes. So this is the absolute maximum time that an eclipse can take, a total lunar eclipse can take, where the moon is absolutely at the minimum distance, and we have actually used the average speed. It should be moving much faster than this, which would give a lesser time interval. Now, if this speed, which we calculated, would be associated with this distance of 1.056 kilometers per second is used, we get 96.4 minutes. Now, as the Earth's shadow is the largest at the moon's closest possible position to the Earth, this should be the maximum length of time that an eclipse can take. But just to be certain, we will repeat the calculation with the moon at the largest distance. And if we do it at the largest distance, which is 4.07 times 10 to the 5 kilometers, we get the size of the shadow as 9123 kilometers. So that's the vertical distance of the shadow. The speed associated with that distance is 0.989 kilometers per second, which would yield a total lunar eclipse time interval 95.2 minutes, much less than the 99.6. But just to be certain that we are getting the maximum possible time, we use the moon's minimum velocity, again from the fact sheet provided by NASA. Let's go there. What is that? It's 0.97. 0.97. So if we use that 0.97, we get 97 minutes, still less than 99.6. So this is still the absolutely maximum time. However, the moon was in totality for 103 minutes on July 27th, which is impossible, another impossibility. So obviously, this could not have been a real total lunar eclipse. So why did NASA stretch the time of this eclipse to an impossibly long length of time? And I'm sure any astronomer who can do this calculation would agree with me. It is impossible for the moon to be in totality for 103 minutes. As I have indicated in article 295, why are so many blood moons being observed? Blood moons are being observed at various times from different positions on the surface of the Earth when it was not possible for the moon to be going through an eclipse. These blood moons are local occurrences as well. A total lunar eclipse is supposed to be a global event, i.e. it is supposed to be seen from everywhere on Earth where the moon can be seen at the time of the eclipse. Thus, the only possible explanation is that moon-like objects which emit red or pink light are all being illuminated by an object that does, or approaching the Earth and are being covered up with holographic projections, or the holographic projection system, which projects moon features in front of these objects. And here's a red moon which was observed from Canada. This is from the YouTube channel Crying Hippie. And this was observed on July 28, 2018, the day after that lunar eclipse that NASA publicized so much, and we observed from the different observatories. Now, it is absolutely impossible for the moon to be in a total lunar eclipse 2 days in a row. It is impossible. The moon does not have an orbit that would make that possible. Also, this was not observed from all over the world. It was observed from Canada. And so, again, we see that this must have been another object in the sky, either emitting red light or being illuminated by red light, which was covered up as a moon. Now, these objects that are approaching the Earth are part of the Planet X system, and most likely planetary and moon cores. And because they are cores, they will look somewhat like Mercury. This is Mercury, but they will be a lot smaller, perhaps between 200 and 1,000 miles in radius. And here you see part of Mercury's core is expected to look like very dense, still rocky. And this would be what Mercury would look like as a dead Mercury, a dead planet. So that's with all its outer layers missing. And this is basically what these objects are. And therefore, this is what they look like. They basically look like the core. And for more details on this, you may look at Article 319 entitled Planet X System, Planets, Moons, and Debris. The moon cores approaching Earth are able to cause tidal events, freak waves, extremely high tides, ocean recession events, severe weather, that is hurricanes, tornadoes, and waterspouts. They can also cause the Earth to shake and fissure as they pass overhead. The wave which creates tidal events over the ocean will cause the solid ground to move backwards and forwards in response to the gravitational wave, resulting in fissures, landslides, and surface earthquakes. They may also cause volcanic eruptions through the same process. And you may look at Article 344 entitled Planet X Objects Reaching Earth and Causing Tidal Events. These objects will gain energy over time as they absorb energy from the Earth. This means that over time the effects will increase until they become absolutely cataclysmic. In conclusion, the maximum possible totality time for a lunar eclipse is 99.6 minutes. It is impossible for a total lunar eclipse to take 103 minutes, and it is impossible to have local total moon eclipses, which seem to be occurring all over the world. This indicates that moon-like objects are approaching the Earth, and an attempt is being made to cover them up as blood moons. The effects that these objects have on the Earth will increase over time and eventually be cataclysmic. Those are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.